in Z
Sir,
axis.
your voice is breaking, sir.
Now, okay, 1 second. Problem. Okay, now you are now is okay. Now, Puchita. Now is it okay? Hello.
Yes, sir.
Okay, ma. Okay. In our last few classes, we are studying about the radiation that is coming from a short dipole antenna. If you place the short dipole antenna in Z axis, in Z direction, okay, we have seen that uh, it has got the vector potential in only Z direction. That's why AZ we have seen. From AZ, we have computed the magnetic field intensity, that is H bar. H bar also we have calculated, and we found that H also has only one component, that is H5 component. The magnetic field in the pi direction. And also we have derived the electric field intensity based on the magnetic field intensity. Okay, we found out that for this short dipole antenna, it has got ER component and E theta component. Okay, in last class we have derived up to there. Okay, now we want to calculate the power flow, the power flow or the power radiated by the current carrying element, or the power radiated by the, simply here you can substitute short dipole antenna. Okay, here the power flow, what is the unit for power flow? What is the unit for power flow per unit area or average power? Can anybody tell me what is the units for average power or power flow per unit area?
Watts per meter square.
Yes, watts per meter square. Here, this is the, we are called, this is the Poynting vector. Poynting vector is used to give the average power. Okay, how to calculate this Poynting vector? P is equal to E cross H bar. We know that the electric field intensity, normally you can write this, it is a vector. It has got R component, theta phi component. Similarly, H also is having R component, theta component, phi component. Okay, in our previous derivation, we have seen that E is having only ER component and E theta component. Similarly, the magnetic field has only phi component. That's why you can write like this. E bar is equal to, it has got these two components. Therefore, ER AR plus E theta A theta. Similarly, magnetic field intensity also, it has got only one component, that is phi component. Therefore, the average power P is equal to E cross H bar. You can calculate E cross H bar. Okay, now substitute E is these two are the terms, and this is the H term. Now perform the vector multiplication or cross multiplication. What is the first term? ER AR cross H5 bar A5 bar. Okay, this is the unit vectors. Therefore, you'll get ER H5. Now, AR cross A5. AR plus A5 is equal to minus A theta. Okay, this is the cross product of these two unit vectors. Okay, normally AR cross A theta is equal to A5. A theta cross A5 is equal to AR. A5 cross AR is equal to A theta. Now here it is AR cross A5. That's why we are getting minus A theta. Similarly, multiply these two terms, cross multiplication E theta H5. A theta cross A5, these are the two unit vectors. A theta cross A5 is nothing but AR. That's why we are getting this one. The power, the average power, okay, it has a pi theta component and it has a R component. And one more important significant observation here is it has a negative sign. Negative sign indicates that the power in other direction. Okay, this PR indicates the power in the positive direction, and this is in the negative direction. Means this PR indicates the power in the main lobe, and P theta indicates the power in the back lobe or minor lobe. Okay, therefore we have to minimize this term P theta. Okay, therefore, in the calculation, where P theta indicates power flow in backward direction, so P theta can be neglected. Therefore, P theta is equal to 0. Okay, now the average power P is equal to, you can calculate from here, P theta multiplied by H5. Okay, this is the E theta multiplied by H5, which has a R direction. That's why PR is equal to H theta multiplied by H5. Earlier, we already computed this E theta and H5, right? In our previous section, previous one. Now, simply substitute and multiply these two terms. You will get, this is the expression we are getting here. Okay. Now, here also, you can see, here we have sine 2 omega t and cos 2 omega t terms are there. These terms indicates that apart from the main lobe, there are some side lobes also is there, side lobe power. These indicates those side lobes. We are interested in the main lobe. That's why we are neglecting this sine 2 omega t and cos 2 omega t terms. Therefore, the average power, here I have written PR, here I have written P. Okay, don't get confused here. This R indicates the direction in the R direction. Okay, the radial direction. Okay, is equal to, see here, I squared d squared sin square theta divided by 16 pi square epsilon, and here omega square divided by r square v square into 2. Okay, this is the average power. Okay, now this is the expression for the average power, the power flow per unit area of a short dipole antenna. Okay, you have to note down this expression. Okay, now we'll see how to calculate the radiation resistance of this short dipole antenna. Okay, now this is understood. Here simply we are uh, calculating the average power by using pointing vector multiplication, substituting these equations. Okay, this E3 and H5 we are arriving at this equation. Here we are omitting these two terms, these terms, 2 omega t terms. This indicates the side lobes. Okay, we have seen main lobe, back lobe, and side lobes. These are the 4 side lobes. We are neglecting these terms. Okay, that's why we are getting the average power like this. Okay, now we want to calculate the radiation resistance of short dipole antenna. Okay, we'll see. Let me share my screen. Wait for it. Okay. Now, the radiation resistance of short dipole antenna. Okay. How to calculate the radiation resistance? Okay. Earlier, from earlier discussion also, we have seen that if you know the total radiated power, P is equal to, the units for P is watts. P is equal to I square RMS into RRAD. This is the radiation resistance. The total radiated power P is equal to I square RMS into RRAD. This is the radiation resistance. Okay. First, we will calculate the average power. Earlier also we have calculated. Here there is another way we can compute the average power, and we will integrate the average power over the entire sphere, entire surface area of the sphere. We will get the total radiated power. From the total radiated power, we get an equation. In that equation, we'll compare this equation with that equation. We will we will get the radiation resistance. Okay, we'll see in step by step. Okay, there is another way to calculate. This is also a Poynting vector here. This here the average power is equal to half times of E and H sine theta. Theta is equal to 90 degrees. That's why we are getting E and H. This is electric field intensity. This is magnetic field intensity. We know the relationship between electric field intensity and magnetic field intensity. That is E by H. E by H is equal to Z. This is the intrinsic impedance. You can write Z or eta naught also you can write. That is equal to 125, or you can write approximately 377 ohms. Okay, now this is the in the average power equation. Substitute E is equal to Hz in this equation. If you substitute E is equal to Hz, you will get Hz H square into Z. The average power is equal to half H square Z. We already know that the magnetic field intensity has got only one component, that is H5 component. We can replace H with H5. Therefore, the average is equal to 1 by 2 times of magnitude of H5 whole square into Z. What is this magnitude of H5? We know this is the H5. Okay. In this equation, earlier also I have mentioned that the numerator, the denominator term, which is having r square, and in some cases we are getting r cube also. This r indicates this is the far field component. R square is a near field component. If r cube is there, that indicates the electrostatic field or the reactive field, which is near the antenna, or you can say that is the boundary sphere around the antenna. Okay, that's why here near field we are neglecting this near field. That's why we are considering only this one. The magnitude of this one is equal to, okay, the magnitude of sine omega t is equal to 1, right? That's why ideal sine theta by 4 pi omega by VR. Magnitude means that negative term will go. Okay, this is the magnitude of H5 component. Now substitute H5 in the equation 2 here. P average equal to square this one. If you square this one, what you will get? 1 by 2 times of P average equal 1 by 2 times of square into Z. Square this one, I square dl square sine square theta divided by 16 pi square. Here this one is omega square V square and R square into Z. Z is equal to square root of mu naught by epsilon naught. This is intrinsic impedance. Okay. Now we have the average power. Okay. Now you have to compare this average power and earlier session. Earlier also we have computed one average power. Both are same. Okay. Here the average power. From the average power, how to compute the total power, total radiated power? That will be this equation. The total radiated power is equal to the integral of the average power over the entire surface area of the sphere. Okay. Therefore, this is equal to double integral P average theta comma pi into ds. What is ds in spherical coordinate system? ds is equal to r square sine theta d theta d phi. Okay, you just simply substitute this equation. You know the P average here and substitute ds here. Okay. Now the total radiated power P is equal to double integral square term. This all sums is there. R square sine theta d theta d phi. We have got only phi term. There is no phi term, right? You can separately you can integrate this phi. Phi varies from, what is the range of phi value? Can anybody tell me what is the range of phi value?
0 to 2 pi.
See, phi varies from 0 to 2 pi and theta varies from 0 to pi. Just substitute here. Okay, if you integrate with respect to phi, you will get 2 pi. I have kept here 2 pi. Now keep only the theta terms inside this integration. What is the theta term here? Sine square theta. Here another sine square theta d theta term. Remaining all are constants, so we can bring it outside. That is 2 pi I square dl square omega square divided by 32 pi square. What is the r square? Here r square term and this r square term will get cancelled. This is square root of mu naught by epsilon naught integral theta is equal to 0 to pi sine cube theta into d theta. Now you have to solve the simple integration. How to solve this integration? Here sine cube theta, you can write it as a sine square theta into sine theta. Here the sine square theta you can write as 1 minus cos square theta. 1 minus cos square theta into sine theta d theta. Let us assume t is equal to cos theta. Okay, let us assume t is equal to cos theta. Now differentiate on both sides. Minus sine theta d theta is equal to dt. Minus sine theta d theta is equal to dt. Or you can write sine theta into d theta is equal to minus dt. Okay. If here theta varies from 0 to pi, now you want to calculate the limits for the t. What happened to when theta is equal to 0, t is equal to cos 0, cos 0 is equal to 1. Similarly, when theta is equal to pi, t is equal to cos pi is equal to minus 1. Okay, t is equal to cos pi, therefore t is equal to minus 1. Substitute in this above equation, and if you solve this equation, okay, here negative term is there, you can interchange the limits, upper limit and lower limit. Now we are getting t is equal to 1 to minus 1, 1 minus t square minus dt. Otherwise, you can write this also integral. This is minus 1 to plus 1, 1 minus t square into dt. To integrate this one, here 1 is there, we will get t square is there, t cube divided by 3, this integration. After substitution, we will get here the term, here the value is 4 by 3. We have to verify this, whether we are getting this or not. Now, 4 ones are 4, 4 fours are 4, 3s are 12. That's why we're getting 12 here. Okay, here this is the expression for the total radiated power. Okay, here in this term, I indicates the maximum current. The relationship between the maximum current and the RMS current is IRMS equal to IM divided by root 2. IRMS equal to IM divided by root 2, or IM is equal to root 2 times of IRMS. Therefore, substitute in place of I, this is actually IM, root 2 times of IRMS, you will get here, see, eta naught. What is the value of eta naught? Eta naught is equal to 125, 120 pi. Therefore, the total radiated power is equal to first eta naught 125 into I square. I square means root 2 IRMS whole square into DL square omega square divided by 12 pi V square. Simply you have written this one. Now do this calculation here. 12 ones are 1, 12 tens are, and here root 2 square means 2 will get 20 pi. This pi and this pi will get cancelled. Therefore, 20 see here, 20 times of I square RMS DL square into omega square divided by V square. Okay, here, what is the omega? Omega is equal to 2 pi f. Therefore, you can write omega is equal to 2 pi f. Omega square means 2 square, 4 pi square and f square. Therefore, 4 pi square will get here. 4 pi square f square. Okay, if you bring down this f here down, v by f square, you can write this is f square here, v square here, v by f whole square. V by f is equal to lambda square. Therefore, you can write here again 4 pi is there, no? 4 pi into 20, 80 pi into pi square. Now, DL by lambda whole square into IRMS square. Are you understand how we are getting this from this equation here? Today the system is a little slow. Okay. Okay, here from this expression, how we are getting this one? Here is that the higher is here is omega, what is omega here? Omega, this omega is equal to 2 pi and 2 pi f. Okay, omega is equal to 2 pi f. Okay, now v by f, what is the value of v by f? What is the value of v by f? V by f is equal to, we already know that this is the lambda.
Lambda.
Lambda, very good. V by f is equal to lambda. Therefore v square here, f square 2 pi f square, omega is equal to 2 pi f square. There, that is 4 pi square. 4 into 20 is equal to 80 and pi square. F square is there. You can write v by f whole square. V by f whole square means lambda square. You can write dl by lambda whole square into IRMS square. Okay, now comparing this equation, we have a total radiated power equation here. Now comparing this equation with the this equation 1. Here this is also total power. IRMS square into RRAD. By comparing these two equation, RRAD is equal to, if we remove this one, 80 pi square dl by lambda whole square. This is also an important derivation. Okay, it will be asked in the examination also. This is the total radiated, sorry, this is the radiation resistance of short dipole antenna. Okay, but now we have to do some small problem. Please note down this problem. Note down this problem and calculate the radiation resistance of an antenna. Here I have given, this is the upper limit and this is the lower limit of a short dipole antenna. Okay, if the length of the antenna is very less, lambda by 50, what will be the radiation resistance? And if the length of the antenna is lambda by 10, and what is the radiation resistance? Please calculate and tell me. From all of you, dear students, all of you have to solve this problem. Okay, what is the expression? Here, note down this expression. RRAD is equal to 80 pi square dl by lambda whole square. dl by lambda whole square. Here, the length of the antenna, length of the antenna is equal to dl. dl is equal to lambda by 10. Okay, dl by lambda is equal to, we will get 1 by 10. Similarly, here also, dl is equal to lambda by 50. Now, dl by lambda is equal to 1 by 50. Substitute here and find out. Dear students, please solve and let me know the answer. All of you, you have to please try this problem. We have to remember this expression. RRAD is equal to 80
7.88 answer.
7.88. Yes, someone. First one is 7.89. 88 ohms. See here, if the length of the antenna is very small, the radiation resistance also very small. If the length of the antenna is quite significant, that it means lambda by 10, the radiation resistance is also very good. Okay, the total radiated power is based on the radiation resistance. Radiation resistance is high, we can the total radiated power is also very high. Okay, please solve this problem also. My next problem.